Hello, today we will look at GNSS frontend. This frontend in particular is capable to work with GPS, GLONASS, Galileo, BeiDou on L1 frequencies. On the front panel we have a connector to personal computer host. This personal computer will be used to keep the recorded digitized IF data. So we use a USB cable 2.0 to connect to PC host. When it is connected, we have power LED lighting up. Now let's look inside of this front end. This is a rigid metal box, so it provides additional shielding. This front end in particular was created with geophysical applications in mind. So it features very high quality clock, oven control clock or O60. This clock provide a clock to the board, and it requires external power. The board also can work without O60 using internal T.Tsujii, which is less precise, but is enough for any navigational purposes, including RTK. But for geophysical applications, in particular, this front end is used for ionospheric scintillation applications, and in this case we use external power supply and O60. This power supply, well, it's it has a changeable plug, so it's adaptable for various sockets. There are two RF pods, front ends. So if we would like to record GPS, Galileo, QZSS, and for example GLONASS, then we have to use two front ends because these systems are on two different central frequencies. We also can use, for example, this RF to record GPS, Galileo and QZSS, and this one to record BeiDou. The digitized signal from RF pods goes into a CPLD device. It could be also FPGA, in this case it's CPLD, which is a programmable digital hardware. This CPLD is used to buffer the signal and compress it and send to the personal computer through USB. We can use JTAG connector, USB cable, to program CPLD device on the fly. We also can send different commands through the control software and change various parameters of the RF front ends using software. Now these front ends, they are working with both passive and active antennas, and for example we can use this antenna for GPS. This is GPS only antenna. The similar one can be used for GPS and GLONASS, and we just connect. Okay, this is a GPS antenna, and this is a GPS and GLONASS antenna. And we can use this front end for various purposes. We can use to record multi-system data, for example GPS, GLONASS, Galileo, QZSS, or GPS, Galileo, QZSS, and BeiDou, or we can use it for various researchers using both front ends for GPS, for example. This could be high sensitivity research when one antenna is located indoors and another outside, or it could be multipath research, or it could be something related to attitude determination when two antennas are on a different attitude. So basically what's important, they use the same high accuracy clock, so the signals can deliver this additional information and can be used together, which often would not be possible if we have just two front ends for the same purposes. So now we can look what kind of signal we can get in the next video. Thank you.